Let's take a look at this. It says for a parallel structure of identical components, the system can succeed if at least one of the components succeeds. Assume that components fail independent of each other, and that each component has a 0.20 probability of failure. Okay. I guess fails would be a good one. Probability that fails is 0.20. Opposite of fails, so we'll go ahead and write that down. I don't know if we'll need it, but probability of fails works. Or is okay or something like that. But keep it to one word explanations on these. Makes them easier. Okay, I think you understand those. Just ask about the 5% cutoff. Let's see. What is probably that parallel structure will, with two identical components, will succeed? Will succeed. Okay. For a parallel structure of identical components, system can succeed if at least one of the components succeeds. Okay. So on B, they're asking, what's probability at least one succeeds? Aha. So at least one. And remember, the word we use for succeeds is at least one works. Well, we rewrite this. 1 minus probability of none works. At this point, it's always 1 minus probability of none. And then whatever word you have here, automatically just carry straight down here. The next step, we rewrite this as 1 minus probability of all. It's always 1 minus probability of all. And then we switch to the opposite of works. Well, the opposite of works is fails. Then we got 1 minus. Probability it's going to fail is 0.20. And the power comes from how many we're talking about. And they say two identical components. So we'll put a 2 here. And I'll plug that in my calculator. And I get 0.96. Okay. It says how many components would be needed in the structure so that the probability the system will succeed is greater than. Okay. So what we're looking at, greater than 0.999. 1 minus 0.20. And then if I think about this, this would be a variable because they're wondering how many. So they're saying how many. Now they say it's greater than 0.99, but let's actually do 0.999 like this. Now this is an exponential equation. To solve an exponential equation, our first step is to get the part of the variable and the exponent by itself. So I'm going to take the this negative 0.20 to the x to the right side. I'll take this 0.999, well, 4 nines, to the left side. You take anything across or equals, your sign changes. So that becomes a negative 0.49, and this becomes a positive 0.20 to the x. Now if I subtract these, that'd give me 0.0001, I believe. 0.20x. There we go. So we got the part with the variable and the exponent by itself. Now our next step is to take natural log of both sides. 0.0001 equals natural log of 0.20x. Our third step in solving an exponential equation is to use properties of logs to get the variable out of the exponent. So we'll take the x and put it out in front. Now try and get x by itself, so we divide both sides by this. So we're going to have natural log of 0.0001 divided by natural log of 0.20. Okay, so let's plug this in our calculator. I'm going to talk about an easier way you could do this. This is a way you can solve it for exact. As soon as my calculator comes up, there we go. Okay. So do natural log 0.0001 close parentheses divided by natural log 0.20. And that gives us x is equal to 5.7 blah blah blah. Okay. Now the question is, how many components would be needed so it's greater than this? Well, if I did exactly 5.7, not that I can do decimals, but if I did exactly 5.7, that would give me equal to that. So if I went down to 5, that would be less than this. So that tells you that you want to go up. X equals 6. You'd always want to go up in this regard. You'd never want to, even if you had 5.1, you'd still want to go up to 6. Okay, the easy way. We know that this setup right here, 1 minus 0.20 to the x. You can go to your calculator. You type in 1 minus 0.20 caret to the first power. That's 1. And that tells you that probability. If I do second enter, I can put 2 in here. Second enter. As I keep putting numbers in here, I'm going to put 5 in. I get this. Second enter. Put 6 in. Eventually you're going to see, okay, there it is, 0.9999. So that tells you that 6 would be the amount you want. Again, that's the easier way instead of using the college algebra.